Hello everyone, thank you very much for joining us for our VisualCAM 2018 for SOLIDWORKS webinar. We're going to be showcasing what's new in this product that we're going to be releasing sometime early next week. Before we get started, there's a few housekeeping tips here. This webinar is being recorded, and we will send you an email to all the people who registered once the webinar is done with the link to the recording. And we'll also reserve last 10 minutes for questions if you have any. But we'd like to keep it very interactive, so if you want to ask us questions during the webinar, you're more than welcome to do that. And then if when you want to ask us a question, just use your chat window. That the red arrow is pointing to that chat window that you'll see on your screen. For you to type the questions. If there's anything we want to demo, we will try to make some time and demo the answers for your questions. So the next slide, please. Yeah, so like I mentioned before, this webinar is what's new in VisualCAM 2018 for SOLIDWORKS. This is a big release for us because we're pretty excited about this release. We've taken some time. Usually we release our products end of the year. The previous year, so we should have released this in 2017 December, but we have taken some time because of the fact that we have been working very hard on introducing CAM and SOLIDWORKS assemblies. A lot of you, our customers, have requested this, and so we have really spent some time working on this functionality, and Uday is going to be showing this later on. And also, of course, our automatic feature detection and machining, which we also introduced in all the other products, we have introduced here as well. So it's really a very nice match with the SOLIDWORKS feature-based modeling, and our feature-based detection and machining. They work hand in hand, and so it's a really powerful combination. And then we'll also be showing all the mill module enhancements, starting from our 2-axis and all the way up to our 5-axis machining functions. And then also, finally, general productivity and user interface enhancements that we have added in 2018, including changes in the toolpath editor, UI, and quite a few things. So without any further ado, I'll let Uday take over and start the demo.
Thank you, Joe. Hello, everyone. Good morning, good afternoon, or good evening, and thank you for joining us for the webinar today. And we are very excited to present to you what's new in VisualCAM 2018 for SOLIDWORKS. And the first thing I would like to present here is the CAM, being able to program your toolpaths, the CAM in assemblies. So I currently have a assembly that's loaded on my screen. I hope everybody is able to see it. If you're having difficulties, please do raise your hand in the GoToMeeting panel, and we'll make sure if there's any issues, we'll get that taken care of. So one of the questions you might have is, why do we need CAM in assemblies, right? So one of the reasons behind it is you can model your machining environment in here, and you can basically be able to model your base, your vices, your sliding jaws, and all the other fixtures that how you typically plan to fixture the part for machining. So you can actually model the entire environment in here, and you can machine the part or parts that you'd like to program in here. So one of the reasons is to be able to model your environment for machining, and also you can machine multiple parts. So you could have one or more parts of the same type or different types, a combination of those. You can program multiple parts with VisualCAM in assemblies now. Now the workflow and the interface is very similar to how we've done it in the part mode. So I'm going to give you a run through of this, how we can program an assembly. So I'm going to switch from the feature tree in here to the VisualCAM tab. Now before I do that, I want to show you here we have different parts, components in here, like we have the base, we have the sliding jaw, and actually the part that we would like to machine in here. So I'm going to switch over to the VisualCAM tab, so you can see the CAM interface now shows up in an assembly document in SOLIDWORKS. And our VisualCAM for SOLIDWORKS is a gold certified product. works in SolidWorks 2011 all the way up to 2018. So if you're running SolidWorks 2018 or anything all the way backward compatible to SolidWorks 2011, you can run our latest version of VisualCAM in SolidWorks. So the browser interface, as you can see, is very similar to what you've noticed in the part document mode. So the first step is to define your machine tool setup, which is the machine tool coordinate system. So by default, the coordinate system is in the same orientation as the world coordinate system in SolidWorks. So in the first step, you would want to establish your orientation of your coordinate system for machining. So you could use from one of these options, or you could say select the surface. I could just go pick a face in here and accept it. You'll now notice that the z-axis is oriented normal to that surface that you picked, and you can also orient your x and y the way you need it. So once you establish your machine tool coordinate system, you can toggle the visibility of the coordinate system on, and the machine tool coordinate system appears right up on your screen. In the next step, you could select your post processor, very similar to how you've done in the part mode. And once you establish the machine in the post, you'd want to go ahead and now define part or parts that you'd like to use for programming in the assembly mode. So this is something new that you will find in assembly. So you can double click on parts and you can select one or more parts. Now if you do not select any part, it'll take into account all of the components on the assembly that you have here. So you could be working with assemblies, sub-assemblies, you'd be able to select these parts. Now as I pick this face, you'll see that it automatically selects the entire part. So this is the part we would like to program. So I have the part selected. I'm going to accept it, and you'll notice that the parts tree is now updated and it displays the part that you've chosen here. So you have one part selected. So like I mentioned, you can have different multiple instances of the same part, or you can have sub-assemblies, multiple parts. You could select all of the parts in here and they would all be listed under parts for machining. So once you've established the part...
Can I just break in for a minute? I just want to interject here. One of the other reasons that we've introduced machining in assemblies is because people want to machine multiple parts. That is, you want to lay out multiple parts on a table, or just lay them out as you would on the machine tool table, and machine it independently, or all the parts at once. So that's why if you look at the tree here, you'll see the instance of each part. So we could have multiple instances of the same part, or you could have instances of different parts here. So that is why we've introduced these instances under each of the part objects. So I hope that makes sense. Thank you, Uday.
Thank you, Joe. So once you defined and selected your parts, the next step is you define your stock material. So you can choose stock, box stock, or part box stock, or if you're running the Pro configuration, you could even do a stock by selection. So you can have your stock modeled in the assembly and you can just select it as well. So here, I'm going to just define it as a box stock in here, and the stock extents are computed based on the part or parts that you've selected from the assembly. So I've defined my stock. I'm going to align it. So you can see that the workflow is very similar to what you've noticed in the part mode in the previous versions of VisualCAM for SolidWorks. In the next step, I'm going to define the work zero, and the work zero, I will set it to the stock box. I'm going to pick high as Z. I'll pick the southwest corner right over here and pick generate. So the work zero is now being set to the top and the southwest corner. We're now ready to program our toolpath. So you could program 2-axis, 3-axis, 4 or 5-axis, depending on the type of operations that you'd like to do. So since this part is prismatic, I'm going to start with a 2-axis or 2.5-axis operation. We'll program a facing operation in here. Use curve edge regions. I'll pick the loop in here, right click and select loop to automatically select the chain of edges. Specify the parameters, like you can pick a tool, you can establish your cutting parameters in here, and then pick generate. So the toolpaths are being generated in the assembly. You can now switch to your simulate tab and run a verification in here. You can also toggle the display of your part visibility on if you'd like to see the fixtures and other components that you built in here during your simulation. So next I'm going to go ahead and program this pocket in here. So go to 2-axis, pocketing. Again, select the features, right click. I could use select tangency or select loop to select the chain of edges in here. Specify the tool, establish feeds and speeds, clearance, your cutting conditions in here. And for the cut levels, I could say determine using 3D model to automatically establish a depth and generate. And again, I can switch back to the Simulate tab to run a verification. So you can program directly from your assembly mode, and saving your work in SOLIDWORKS automatically saves all of your CAM information in the assembly file as well. So if you hit save, all of the CAM information that you program gets saved in here. You can take a look at your estimated machining time and then do a post process to post it out to your machine tool. And there's your posted code program from an assembly. Folks, if you do have any questions, please feel free to post those questions in the questions panel and we'll be more than happy to get to them. Now the next thing I would like to go over here is our new features that we've added. We're going to cover, the first thing we're going to be covering is feature detection and machining. And to go over this, I'm going to go ahead and bring in a part where we're going to go ahead and program, we're going to show you how we can automatically detect features and how you could, basically be able to select those features and automatically generate some toolpaths with it. So to demonstrate this, I have a part loaded in here. So in this particular case, you can see I'm working in the part mode in SOLIDWORKS. And I have a prismatic part. As you can see, the part has several different types of features. You can see pockets, slots, open slots, holes, chamfers. So all of these different features that you model in SOLIDWORKS can automatically be detected in our latest version of VisualCAM. And you can identify, you can find these by going down to the Features tab. The Features tab is part of the Machining Objects browser. So if you do not see the Machining Objects browser, you can click on Tools, Machining Objects to toggle the visibility on, and then click on Features, and that'll take you to the Features tab. Now in the Features tab, you have Automatic Feature Detection. So as you select this, VisualCAM will automatically identify the features on this part. So we have different types of features that we could identify. We have silhouette features, which identifies a silhouette around the part. You have planar faces in here, which can be used for programming like facing operations. You could use it for profiling as well. You have prismatic pockets. You could identify closed pockets as well as open prismatic pockets. Now, as I'm selecting each of these features in the tree, you will see that the tooltip preview also gives you the information about the depth and also additional information. If you're working in a hole feature, it also gives you the depth and the diameter of the hole. So you can see hole features are also being identified in here. So for each of the orientations are also identified as well. So in this case, we have chamfer features in here and a prismatic slot. So all of the features for any given orientation are identified. Now, by default, the features are identified based on the orientation of the machine tool coordinate system that you've established. If you're running the standard configuration, there's only going to be one orientation that will be defined. If you're using the expert configuration, it'll be able to identify features from all the 4 sides that are along your rotational axis. If you're running the pro configuration, it could be from any of the 6 sides. If you consider a box, you have 6 faces. It'll identify features from each of those 6 different orientations. So in this particular case, we have 2 orientations, one on the top and then one on the bottom. You can see from the bottom there's a planar face, and then the whole features are being identified in here as well. Now, once you have these features identified, you could just select the orientation, and selecting automatic feature machining automatically generates the toolpath for each of these features. So there's a knowledge base that resides in the installed directory, and it automatically matches the features to the operation. So for a planar face, you could program a facing operation. For open pockets, you could be programming a facing operation. As you can see right here, the open pocket uses a facing. For closed pockets, you have pocketing, and then you can do a finish operation with a profile operation for both open and closed pockets. You could do a profile for the silhouette features, a slot machining operation for machining the slots, And for the hole features, you could do drilling, and for the chamfer features, you could apply a chamfer operation. So once you have all of these programmed, you could select the setup, right-click, and do a simulate to run a verification. So with just a single button click, we were able to automatically detect the features, and once the features were detected, we used automatic feature machining to automatically generate toolpaths for each of those features that were automatically detected. So in just a couple of button pokes, you're fully able to program parts like these prismatic parts using feature detection and machining. Now, just to give you a little bit overview of the type of features that can be identified in our latest release, I have a little chart in here which talks about the different types of features. So depending on the parts that you model, we have hole features, prismatic pockets, closed pockets, open pockets. We could identify boss features, pocket features which you have, where you could have sculpted bottoms. We call them as general pocket features. Slot, we can identify both closed and open slots, open slot features, T-slot, V-slot, 3-axis open pockets, planar faces, fillet features, chamfer, stepped prismatic pocket, and silhouette features. These are the different feature types that can be detected automatically based on the parts that you modeled or that you may have imported into SolidWorks.
I just want to, can you bring up the chart again? Thank you. So for our attendees who are using other products like RhinoCAM or VisualCAM, one of the things you might notice is we have added the silhouette feature, which is a brand new addition that has added into the SolidWorks product, but we will also be backporting it back to these RhinoCAM as well as the VisualCAM standalone products and releasing a service pack pretty soon. So you will be able to use that silhouette feature in the 2018 release of the other products as well. Thanks, Uday.
Thank you, Joe. So what we just talked about here was automatic feature detection, and we did automatic feature machining. The next thing I would like to go over here is interactive feature detection and interactive feature machining in here. And to demonstrate this, I'm going to go ahead and bring in another example, and we can take a look at how we could interactively detect features and also program them by selecting a certain features. So in this particular example here, you can see that I have some features on an inclined plane. So when you perform an automatic feature detection, it's only going to identify features that are from the 6 different orientations if there are any features on it. In this particular case, there's a feature on the top face, which is part of the orientation number 1, as you can see right there. And there's also an orientation number 2, which is on the right side face. The automatic feature detection will not identify features if you have it on an inclined plane. So to be able to identify features on inclined planes, you could use interactive feature detection. We call it IFD. You can select interactive feature detection, and it'll ask you to pick a plane. You can pick a face. I can just go pick that surface right in here, and when you accept it, it automatically identifies the features on that particular face. So it basically uses a face to establish the normals, and it automatically identifies the features in that particular orientation. So I could have selected this face, or I could even selected the floor of the pocket in here. So as you can see, the orientation 3 now has a planar face and also has a prismatic pocket. It also identifies the depth of these pockets for you automatically. So once you've identified these features either using automatic or interactive, you could interactively select these features and program them. So if you hover your cursor right on top of these features, you'll see that the tooltip automatically displays what features these are. You have a planar face, you have a prismatic slot feature. So again, if I go over to the the inclined plane, you can see there's a prismatic pocket feature, and there's one over here. So as you hover your cursor over here, you can select this face, right click on it, and it gives you the operations that you can program. So for a planar face, you could be programming using a facing operation, or you could do a two-axis roughing or profiling. So in this particular step, I'm going to pick facing, and then you can see that all of the parameters are automatically established, like your depth and all the parameters. All you have to do is generate to compute the toolpath. So we now generated a toolpath for the facing operation, and I'm going to select the pocket in here, right-click and start with a pocketing operation in here, and you can see that the depth is automatically determined based off the feature. If you need to specify or modify or adjust your depth per cut, you can always edit those in the cut levels dialog. And finally, I'm going to add a profiling operation to finish this up in here with the same tool and select generate.
The key thing to observe here is that as Uday is selecting these features interactively, the system computes the appropriate toolpath methods that are applicable to that particular feature and displays them in the right mouse menu. That's an important thing to remember. So we're not displaying all the operations. So if you go and hit the right mouse menu, you can see that's a slot. And the only applicable operation or allowable operation is a slotting operation. So that's why it shows up there. So that's a very important feature that you should be aware of. Thanks, Uday.
Thank you, Joe. So you could interactively select features and program it, or you could do automatic. So these feature detection and machining are available right from our standard configuration. So if you're running standard, expert, professional, or premium configuration, you'll have access to feature detection and machining in our latest release of VisualCAM for SolidWorks. So folks, again, if you do have any questions, you're welcome to post those questions in the questions panel, and we'll be happy to answer them for you.
Yeah, well, there was a question about the assemblies. Is that available on all the configurations? And yes, assemblies, CAM and assemblies is available in all configurations, starting from the express configuration. But the feature-based machining is only available starting from the standard configuration. All right, thanks, Uday.
Thank you. All right, so the next thing I would like to cover here is a brand new method that we've added in 2-axis or 2.5-axis machining, and this method is called fillet machining, and this is available in all our configurations starting with standard. So any configuration standard or above will include fillet machining. We talked about the detection of fillet features in feature detection machining. So you can identify fillet features using feature detection in here. So you can see as you run a feature detection, you'll see that it automatically identifies the fillet features on a part. You can right click and choose filleting. So it automatically programs a filleting operation. Or you could use the traditional way of programming it by going into 2-axis, and you can select a filleting operation from the menu, and you can pick your chain of face edges as your control geometry, and with the use of a filleting tool, like a fillet milling tool in here, you can define a filleting tool that matches the radius of the fillet, and you can program a fillet operation. So this would allow you to machine fillets very effectively in here, and you can generate and program fillets easily using the new operation, which is called filleting or fillet machining, and it's available in 2-axis or 2.5-axis, and this comes right from the standard configuration. So if you have standard or any of the above configurations, you will be able to program fillet machining.
Note on fillet machining, it's only applicable to fillets that are horizontal, and we don't handle multiple radius fillets or variable radii fillets. So the fillets have to be constant radius, and they also have to be horizontal with respect to the machining orientation.
Thank you. As part of the feature detection, we've also introduced the ability to automatically identify chamfer features. So on this particular model, you can see there's chamfers on these inside pockets, and these can also be detected in here automatically, and you can program chamfer operations in here on the toolpath. So you can right-click on a chamfer feature and choose chamfering, and it automatically determines the depth and all the parameters, and also it gives you information about what the angle is. If you just basically select it here, the preview shows the depth and also the angle. So if you have a 45-degree V-bit or a chamfer tool, you can program a chamfer operation for these chamfer features. So these are some of the very nice improvements and enhancements that have been added to the two-axis methods. So again, the filleting and the chamfer methods can be found under the two-axis menu, or if you're using feature detection, after you identify the feature, you can right-click on the feature and it automatically allows you to select the operation. One of the other ways to program this would be you just highlight the chamfers under the feature tree and you can click on automatic feature machining and it'll program all of the chamfers that you've identified in here as well. Now the next enhancement or improvement I would like to cover here is the improvements that have been added to the high-speed pocketing, high-speed cut patterns that are available in two-axis pocketing, two-axis slot machining, and also in our three-axis roughing operation, the horizontal roughing. So there's been improvements made to the high-speed cut pattern, and we have had enhancements and bug fixes to the high-speed pocketing cut pattern. So it's very robust, and it handles a large cases very well. So you can see here the high-speed pocketing cut pattern can be found under the two-axis pocketing menu, and you can select the cut pattern to be high-speed. And there's been improvements made to the high-speed cut pattern in pocketing as well as slot machining and the three-axis roughing method. Now the high-speed option for cut pattern is available in all configurations starting with standard. So if you're running standard, expert, pro, or premium, you will have access to the high-speed cut pattern in pocketing, in slot machining, and in three-axis horizontal roughing.
For people who may not be familiar with the high-speed cut pattern, what it really is it's some people call it constant engage cut patterns. What it does is it tries to maintain the cutter in tangency at all points in the toolpath. So you're going to eliminate a lot of jerky motions on your machine tool where the tool is actually, or the machine tool is actually abruptly changing directions. So this tool cut pattern eliminates a lot of those abrupt motions and maintains constant tangencies at most of the cutting areas, as you can see. So uses a lot of arcs. It might be a little more time you're going to be spending on the machining, but it's a lot more efficient in terms of material removal. So it's a very, very nice feature. If you haven't tried it, I suggest strongly please try that on your machine.
Thank you, Joe. The next thing, folks, we're going to talk about is enhancements and improvements to three-axis machining methods. There's been numerous improvements and enhancements that have been added in our latest release, and one of the enhancements I'm going to cover today is an enhancement to horizontal finishing toolpath in our latest release. Now the horizontal finishing operation again is available in configuration starting from standard and above. So if you're running standard, expert, pro, or premium, you will have access to three-axis and horizontal finishing, and this would be in the three-axis menu. You'll find horizontal finishing in here. Now in our previous versions, we used to do what is called retract to clearance when you had within transfer motions and you have a containment selected. Now in 2018, we've added a new option which is called follow containment. So the toolpath will actually follow along the containment region, as you can see here, right here. And this option can be found under the cut parameters tab in your horizontal finishing operation. So you have follow containment, or you could pick the default one, which used to be in the previous version was a retract to clearance. So you can choose between retract to clearance, or you could do a follow containment. It follows along the containment boundary that you selected in here. So it eliminates the retracts and the transfer motions and makes it easier on machining. Again, this option is available to you in horizontal finishing, and it's included right from our standard configuration of the product. Now, there's also been improvements made to other 3-axis methods. For example, if you look at 3-axis parallel finishing, we've now added the option to sort. So if you have one or more containment regions selected, you can sort basically based on minimum distance or directional sort, similar to how you have sorting options available in other 2-axis methods that you may be familiar with, like pocketing, profiling. So you have sorting options available in 3-axis parallel finishing and also in 3D projection pocketing methods and other methods in the latest version of VisualCAM for SOLIDWORKS. And there's also been other numerous improvements and bug fixes to horizontal roughing and horizontal finishing in terms of Z-level ordering, and there's been numerous improvements and bug fixes as well, in addition to these new features and enhancements in 3-axis methods. Folks, again, if you do have any questions, please feel free to post those questions in the questions panel, and we'll try to get to those questions. So the next thing we're going to talk about is some of the new features and enhancements to our 4-axis methods. Now, the 4-axis methods are included starting with expert configuration. So if you're running expert, or if you're running pro or premium, 4-axis methods are included with it. And in 4-axis methods, you could program it on a rotary axis, which could be like a rotary table, where the part would be rotating on a rotary chuck. So with the 4-axis methods, we now introduced a new 4-axis method called create round operation. Now, in most applications where you do like woodworking or other type of applications, you might be starting with a rectangular block of stock material on your workpiece, and you would want to basically remove these excessive materials in those corners of the stock material. So to be able to program this, we've introduced a new operation called create round operation, and it automatically identifies the material in those corners based on the stock geometry that you define and based on the part that you're trying to program in here, and creates a toolpath, generates a toolpath to remove these excessive materials to the corner, so it makes it easier for you to further machining for the additional operations that you're looking to program. So you could program this as your first operation, basically turn the rectangular stock into a round stock geometry, and then add additional operations you could be programming with the roughing, pre-finishing, and finishing operations with it. So create round is a new operation that is available in the 4-axis methods, and the 4-axis methods are included starting with our expert configuration of VisualCAM. Now, I would also like to highlight some of the improvements that you made to the 4-axis methods, like parallel finishing. There's a brand new cut pattern that we've introduced in 4-axis parallel finishing, and that's called a helical cut pattern. So as you can notice, the toolpath in here, it creates a continuous helical pattern, so it eliminates the step over marks. As you may have noticed when you're using a cross cut pattern or a long axis cut pattern, there's a new option to also use a helical cut pattern, and this can be found under the cut parameters tab in 4-axis parallel finishing, and you'll see helix as a new option in here for the cut pattern. So this creates a nice helical cut pattern, and it can be used for a variety of different applications. So there's a helical cut pattern preview in here, and I have another example here where you can see the helical cut pattern with a much tighter step over that you can apply in 4-axis parallel finishing. Folks, again, if you do have any questions, please feel free to post those questions in the questions panel, and we'll try to get those questions answered for you. So the next topic I would like to cover here is being able to program true 4-axis or simultaneous 4-axis toolpaths using our premium configuration. So the premium configuration offers full 5-axis capabilities, simultaneous 5-axis machining capabilities, and now we've introduced an option where you'd be able to lock it to a 4-axis. So if you only have a 4-axis machine tool, and you would like to be able to take advantage of some of these true 5-axis methods but lock it to 4-axis, we now have the option to do that in our 2018 release. So on any of the 5-axis methods which are included in our premium configuration, we now have an option to lock the axis to a 4-axis output. So it'll lock it to the plane, so it'll have 3 linear and a rotational axis. It'll be a true 4-axis motion. And if you only have a 4-axis machine tool, then you can set the number of axes to output as 4-axis and program parts like these. This is like a twisted rail where you can program using a continuous or a simultaneous 5-axis method, but lock the axis to 4-axis. And I'm going to run a quick verification in here so you can see the simulation of the animation of the toolpath. So this will output a true 4-axis.
Yeah, when Uday says true 4-axis or locking the 4-axis, what he means by that is the tool is constrained to parallel planes that are normal to the rotary axis of the machine. So in a 4-axis machine, obviously you can only change the tool axis in a plane that is normal to your rotary axis of the machine. But in our traditional wrap methods, we keep the tool axis normal to the rotary axis. But what we do in these kind of methods where you have some parts like twisted rails, we need to actually vary the normals along the surface normal. And that's what we do. And the normal of the tool, even though it's constrained to planes that are parallel, or I'm sorry, normal to the rotary axis, can vary in both two directions, that is. So that's why he's calling it a true 4-axis as opposed to a wrap 4-axis where you only have three, in reality, just 3 axes moving, X, Y, and a rotary axis. Here you can have X, Y, Z and a rotary axis moving at the same time. I hope that makes sense. Thanks.
Thank you, Joe. So folks, if you do have any questions, you're welcome to post those questions in the questions panel. So now this true 4-axis method, which can be programmed using the simultaneous 5-axis methods, is available in our premium configuration, and you could use these from any of these 5-axis methods: curve projection, flow curve, between two curve, drive curve, surface normal, or swarf. So the example here, what we've shown here is a between two curve machining, and we've locked it to a 4-axis. So if you only have a 4-axis machine, you could pick the option to lock it to 4-axis and be able to program it on the 4-axis machine tool. Now the next enhancement we would like to cover here is new features that we've added to simulation and for holder collision. So to demonstrate this, I'm going to go ahead and bring in another example in here, and we will cover this in the next topic here. So holder collision is a very important feature that allows you to determine if the tool that you're using or the tool length is either long enough or not for the part you're trying to machine. So you can actually check this before you actually put it out to your machine. You send a posted card out to your machine. So if you model your tools in the VisualCAM by defining your tool length, the flute length, the properties in here, and you program your tool paths based off that information that you put in, and as you run your verification or simulation, you will notice that if there is a holder collision, so I'm going to go ahead and toggle the display of the stock visibility on and go back and run the simulation in here. And as you notice any collisions in here, you'll see that it not only flags the collision areas as red in the simulation, but you'll also notice that the machining operation is now flagged dirty. And if you go into your toolpath editor or the toolpath viewer, you can actually see the toolpath motions that causes the collision, causes the holder collision. So as you scroll through your toolpath viewer, which is available right from our standard configuration, or the toolpath editor, which is included in Pro and Premium configurations, you will see that it marks the go-to motions where you run into a holder collision. So here you can see that these lines in here would result in a holder collision, and it also automatically marks those collision areas in the toolpath viewer or toolpath editor. So for each of the areas where there's a hold a collision, it'll mark it. Now, how would you correct this here? You can either restrict the Z step down. If you're doing a pocketing operation, you can based on the tool length, or you may have to use a tool that's longer than what you already selected in here to avoid collisions. So the hold a collision is a very nice feature in here, and it also marks those collision areas in the toolpath viewer or toolpath editor, in addition to flagging the machining operation as dirty, and also marking those collision areas in the simulations. You can see the collisions are marked in red.
Uday, can you show them how to determine the length of the tool as well?
Sure. So I'm going to go over to the Tools tab, and if you click on Compute Holder Collisions, it'll tell you the minimum tool length that you'll be needing to avoid collisions. And I believe this option is available starting with our Pro configuration, the Detect Holder Collision Areas. So it recommends that I set the tool length to 1.5125 to avoid any collisions. And I can select OK, edit the tool, and I can go back and change the tool length in here. Save my edits. And now it'll go back and determine that there's no holder collisions detected. And I'm going to regenerate this operation in here. When I perform a simulation, you'll see that there were no collisions detected, and the operation is marked clean, so it's not flagged dirty. And if you go into your toolpath viewer, there aren't any collisions being detected in here as well. I hope this answers your question. Now, one of the other improvements I would also like to point out is improvements to machine tool simulation in our latest release. We've not only added newer machine tool models, so if you go into the machine tool definition and pick load from file, we've added several new additional machine tool models in here to the list. And also we made improvements and enhancements and fixes to existing machine tool simulation issues as well. So in this particular example here, I'm going to go ahead and select a CNC mill, a 3-axis mill as an example, to perform a machine tool simulation. So the machine tool simulation is offered right from our expert configuration. So if you have expert, pro, or premium configuration of our product, you could perform machine tool simulation. So you just have to toggle the machine tool simulation visibility on once you've selected the machine tool. And then as you run the simulation here, you'll see the simulation being performed with the machine tool. And if you have any machine tool, the machine tool that you're using is not listed in here, we could always add the new machine tool to the list. So we would need the machine tool models. Very similar to how we can develop new posts, we can also add machine tools, additional machine tools to the library of machine tools. And you can drop us an email to support@mecsoft.com and we can help you with that. Folks, if you have any additional questions or any questions about what we demoed today in the What's New webinar, I'll be more than happy to answer them for you. And with this, I would like to hand it back to Joe.
Yeah, thanks, Uday. That was a great demo. As you can see, there's a lot of new features in our product. One of the questions that came up, Uday, was when is this product going to be released? And as you might have noticed, we still have some work left in terms of the graphic design. So we're waiting on some of the graphic design pictures and bitmaps to arrive, and our plan is to release this product early next week. It's been through QA and it's pretty robust right now, and we're planning on releasing it early next week, and we'll be sending out an announcement once it's ready. It's either early next week or mid next week is our release plans for this product. So looks like we don't have any more questions. We can pause for a few moments if you have any other questions, anything that you would want us to demo, and we'll wait. Okay, looks like no questions from our attendees. So thank you very much for all of you for attending. As we mentioned in the outset, we have recorded this webinar, and we'll be sending it out to you by email in a day or so once we process it. And thanks again, and take care.